Let's now take a look at how we can manipulate the tree nodes that we spoke about in the earlier part. Let me just make one more quick remark. If you look at the runtime structure that we visualize over here, you can definitely choose either this one over here or this one over here. I will show you maybe one that's even simpler just for effective tracing, but we'll talk about it. I want to talk about this comparison over here. If you look at the runtime structure, let's say for the tree nodes over here, you can think about the parents is really going to the reference above for the node over here, right? So that's kind of analogous to the previous reference for a doubly linked node. On the other hand, for a general tree, in the case of the children over here, you can see it's not a single reference, rather it's actually an array of references over here. That's really the branching out structure. For example, if I got my root over here, I may just need to branch out to child number 1, child number 2, and child number 3. So that's why the structure over here is non-linear. On the other hand, if you think about the next reference over here, it's only a single one. So you always get a unique path to really go to the next one, your successor. On the other hand, in the case of the tree, you simply don't have just a unique. In general, you can have as many as likely, depending on your application, right? This again illustrates about the nonlinear versus linear structure. Nonlinear over here versus linear over here. Right? It's a very important comparison I would like you to do also by yourself. Just make sure you understand. Right, let's now go back. So the first manipulation I would like to talk about is about how you can build a simple tree. I'm going to give you some very simple illustration just about how to set the references. And you can do other more complicated example yourself. Right, let's now talk about this one here. Right, so let's say we're trying to create a 3-node tree. That's what we're doing. Right, let's say the root over here is a agna over here, right? So that will be the node. Okay, as I said, as we covered before, you can leave this part over here simply just empty angle bracket. Compiler can figure out exactly what the type is. In this case, it would be a string, right? So what we do is we have a node, let's say agna, simply pointing to a node over here, and we only pass the data objects over here. And the parents and also the children will just be initialized accordingly, right? So for example, the parent reference, I don't need to say parents, but the fact that I'm drawing this vertically, that means it's a parent reference, right? That's the simplest way I can think of to visualize it. So this will be simply just null, right? And also we got the data objects over here. I also don't need to do that because it's going to be a single reference, and it's going to be agna, right? So let me just move this a little bit so I got enough space. Actually, I think that's okay, right? So it's going to be the data objects. And for the children, how should we initialize it? According to our definition earlier, we're going to simply create an array of the maximum size. In that case, it's going to be 10, right? For our example. So what we're going to do is we're going to simply create an array over here, and then we got different array indices, right? 0, 1, all the way to just 9. So this will be the first part. You can think about the first line over here, simply constructed just a single node. And we intend to treat this node as the root of the tree. And we want to add 2 child nodes to it. Let's see how we can do that. This will be the line for the first child over here. And this will be the line for the second child. And for the second one, let's use blue to highlight it. Elsa. And Elsa is just another tree node. And this will have this identical structure as agna. So what I can do is I can simply copy this part over here. I'm going to just change the data objects in a moment. Copy. And the first child, let me just put it over here. Okay. I think that might be good enough. How about here? All right. And let me just save the structure over here just for later, for the second child. And also for this one here, let me use a different color. How about just blue over here? And the reference will be Elsa. So this will be just another node whose address is stored in variable Elsa. And the parents will still be null to begin with, but the data objects rather than agna, of course, is going to be Elsa. Alrighty, so that's the first one. And we don't really set a parent's reference just yet. So as for now, this node and this node has nothing to do with each other, not just yet. What about the third node? For the third node, let me use orange. So I'm going to put Anna, the third node, and the structure, the process will be just the same. So let me paste it over here. Let me just put a little bit higher. Okay, you can see that. And let's now change that to be orange. Right, so just the data objects need to be different. So we got Anna, and also the data object should be a string Anna. Now this will be the reference name Anna, and also storing the string Anna. So far it's very straightforward. We have created 3 nodes in isolation. This part over here will be the most critical part to really set up the structure. And the way we do this is very similar to how we set the previous and next references as before when we talk about the linked list. So for this part, let's just visualize exactly. And we got add child over here, and also add child. So here the order is very important. We want to add the child for Agna over here by Elsa and Anna, right? You can see Agna over here. The first child, meaning that at index 0 is going to point to wherever Elsa is pointing to over here. So it's going to point to this one here. And the second child is going to be at index 1. That is going to point to wherever Anna is pointing to, right? These are very basic OOP manipulations. I will need to rely on you. If you want to do the tracing on the Eclipse, you're more than encouraged to do so. But just make sure you know how it works. If you got trouble, you should really reach out to me. And that's only about one direction. We're setting the parents to children to be Elsa and also Anna. But symmetry is not completely just yet. We have to make sure Elsa's parents should be Agna, and also Anna's parents should also be Agna. Remember when we talk about the formal definition of the tree, the parent-children properties must be satisfied, meaning that the symmetry. Let's now talk about the other half. We also have to make sure, let me use maybe this color here, the Elsa parents and Anna parents must be set to both Agna because they are siblings. So Elsa's parents, rather than pointing to null, is actually going to point to Agna over here. And also Anna's parents over here is also going to point to over here Agna, right? Let me just highlight all these 4 references we have set up over here. So we got first child, second child for Agna. And also we have the parents of Elsa, and also we got the parents of Anna over here, right? So these are the 4 symmetric references that should be done. So you just make sure these 4 lines actually do the magic about setting up the references. And of course, if you now try to do the assertion, let's do that quickly. Agna.getParents would just be null. Agna will be Elsa's getParents, right? Of course, Elsa.getParents is going to be just this object over here, which is being pointed to by Agna. Apparently, you got aliasing over here, right? You can see Agna and also Elsa.getParents, both of them actually point to the same objects. So this is definitely aliasing. Let me just highlight it quickly. So these 2 assertions actually demonstrate aliasing. Right, that's quite important. And also, what about adding children? And for that one there, I'll refer you to this fragment of code. If you go back to the source code made available to you, go to tree notes, and then you'll see how we can manipulate the NOC, the counter over here. So go to the add child method over here. You can see this is exactly how things work, right? I'll let you trace it. It's very basic, which you should really learn about maybe from the second year. I mean the 2030, I meant. If you got any trouble understanding these 2 lines of code, how you work between the calls to add child, reach out to me. All right. Right. So this part over here, Agna.getChildren over here is going to return just an array, right? Over here, let me just trace this code together with you. So this part over here, Agna.getChildren is just going to return an array whose length will correspond to the number of children. You can see this array over here is of size 10, always, right? It's a maximum size. However, the number of children is only 2 in this case. So when you say Agna.getChildren over here is simply just going to return an array of size 2, right? You can think about this part here is really Agna dot get children. The size has to be matching the number of children at the moment. So it's simply just going to be 2 elements here, right? Let me draw better for the array. It's going to be exactly 2 elements here, and 0 and 1. Index 0 is actually going to point to the first child, which will be Elsa over here. And index 1 is going to point to Anna, right? I'll try not to really cross the lines as much as possible, so this will be pointing to Anna over here, right? Again, we got aliasing. How come? So there are 2 occasions. And let me highlight them first. These 2 assertions over here. And they are to do with the return value of egna.getChildren over here, and either index 0 or index 1 over here. Let's now visualize it. So egna.getChildren will be this array of size 2. In that case, index 0 is pointing to the same object as Elsa does. So that's aliasing number 1. What about number 2? egna.getChildren at index 1 is pointing to where Anna is pointing to. So that's aliasing scenario number 2, right? So that's why we got these 2 aliasing scenarios as well, right? So we got 1, 2, 3, 4 aliasing instances. And you definitely should know these are the important phenomenon to really make sure the symmetric references of parents and children have been set up correctly. And let's now move on to the next part, which is to define utility methods like a depth and heights on the nodes or on the tree.